Welcome everyone. This video is Lesson 8 of Module 1 for Grade 7. We're going to be talking about representing proportional relationships with equations. In this first example, we want to know, do we have enough gas to make it to the gas station? Your mother has accelerated onto the interstate beginning a long road trip, and you notice that the little fuel light is on, indicating or meaning that there is a half a gallon left in the gas tank. The nearest gas station is 26 miles away. Your mother keeps a log where she records the mileage and the number of gallons purchased each time she fills up the tank. Use the information in the table below to determine whether you will make it to the gas station before the gas runs out. You know that if you can determine the amount of gas that our car consumes in a particular number of miles, then you can determine whether or not you can make it to the next gas station. So here's your mother's gas record. The first entry says that when she had 8 gallons, she was able to go 224 miles. When she had 10 gallons, she was able to go 280 miles. And when she had 4 gallons, she was able to go 112 miles. Our first question asks us to find the constant of proportionality and explain what it represents in this question, or in this situation. That's really important, what it represents in this situation. So we're going to be using words that have to deal with this problem specifically. To find the constant of proportionality, we want to divide the miles driven by the number of gallons. So we're going to take each of our miles driven and divide it by the number of gallons. We're looking to see if we get the same value for each ratio. First we do 224 divided by 8. That gives us 28. Then we do 280 divided by 10, which also gives us 28. And finally, 112 divided by 4, which also gives us 28. So our constant of proportionality is 28 miles in 1 gallon. And remember, the letter K is what we use to determine or to describe the constant of proportionality. We often say K equals a number. In Part B, we want to write an equation or equations that will relate the miles driven to the number of gallons of gas. So if we use like the letter M for miles driven and the letter G for the gallons of gas, we could find out how it works. We could use those variables. To find out how many miles the car can go, we're going to multiply the constant of proportionality times the number of gallons. And we're going to use miles equals K, the constant of proportionality, times gallons. If we substitute 28 for K, here's our equation. If we use variables, M for miles and G for gallons, then this is what our equation looks for. We can often use Y and X. When we don't have a word to go with our variables Y and X is always what's going to be multiplied by our constant of proportionality, and Y will always be what we get when we do the multiplication. Let's take a look at number C. Knowing that there's 1/2 of a gallon left in the gas tank when the light comes on, will she make it to the nearest gas station? Explain why or why not. Well, our equation is miles equals 28 times the number of gallons, and we have a 1/2 gallon of gas. So we're going to substitute 1/2 for the number of gallons and multiply. Miles equals 28 times 1/2 gallons, so we can go 14 miles on 1/2 of a gallon. In our problem, it said that the nearest gas station was 26 miles away. Well, we only have enough gas for 14 miles. So you cannot make it to the gas station. You would need enough gas to go 26 miles, and we only have enough gas to go 14 miles. Well, now that we've figured out, we can use the equation we found in Part B to determine how far your mother can travel on 18 gallons of gas. And we're going to solve the problem 2 different ways, once using the constant of proportionality, and then once using an equation. Well, when we did it before, we just multiplied the number of miles for 1 gallon times the number of gallons, and that gave us 504 miles on 18 gallons. If we use an equation, miles equals 28 times the number of gallons, we can substitute 18 gallons for G. And when we multiply those out, we get 504 again. As you can see, these two equations look very, very similar. We've just started out like this. Now let's try using the constant of proportionality and then an equation to determine how many gallons of gas would be needed to travel 750 miles. This is kind of like the deer problem in the last video. If we know how many miles we want to go, and we know how many miles we can go on 1 gallon, dividing the two numbers will give us the number of gallons that we need. If we use the equation, though, we're going to substitute 750 miles for m, and we get this one-step equation. 750 equals 28 times g. To solve one-step equations, we're going to divide both sides by 28 to find g. It'll look like this. 750 divided by 28 is 26 8/10 gallons. That's what the g here tells us. Either way, we divided 750 by 28, whether we did it using the constant of proportionality or using the equation. In example 2, we're going to look at how you can use a graph to come up with the constant of proportionality as well. In this example, Andrea is a street artist in New Orleans. She draws caricatures, cartoon-like portraits of tourists. People have their portrait drawn and then come back later to pick it up from her. The graph below shows the relationship between the number of portraits she draws, that's on the y-axis, and the amount of time in hours she needs to draw the portraits, that's on the the x-axis. And as you can see, the number of portraits drawn is represented by a capital N, and the time spent drawing portraits is represented by a capital T. First, we're going to write several ordered pairs from the graph and explain what each ordered pair means in the context of this graph, so based on the information in this graph. When we pick up ordered pairs, we could pick them from anywhere along the line, but it makes it easier if we pick them where the line crosses two places on the graph. So let's take a look at our first point. Right here, for 2 hours, she can draw 3 portraits. It's that point right there. If we were to write the ordered pair for that, we would write 2, 3, which means that in 2 hours, Andrea can draw 3 portraits. Okay, let's find another point. If I go up to the 4, it crosses the line right at 6. And this means that in 4 hours, Andrea can draw 6 portraits, so this is the point 4, 6. Another one we can find is right here. In 6 hours, Andrea can draw 9 portraits. So that's the point 6, 9. Now, sometimes we can find a point that's not on a whole number. If you look at this point right here, where in 1 hour, it looks like it crosses it right at 1.5. So in 1 hour, she can draw 1.5 portraits. And this is an important point. Where the line crosses at 1 unit on the x-axis, that's the unit rate. So let's take a look at this as an equation. We're going to write several equations that would relate the number of portraits drawn to the time spent drawing the portraits. And we're going to use those points we came up with. We're going to use the equation, the number of portraits equals the constant of proportionality times the amount of time. And remember, we can divide y by x to get the constant of proportionality. So in the first equation, she can draw 3 portraits in 2 hours. 3 was our y coordinate, 2 was our x coordinate. That's the same as the equation n equals 6/4 times t. She could draw 6 portraits in 4 hours. We can also write the equation n equals 9/6 t, 9 portraits in 6 hours. Now these are all the same equation because 2/3 is the same as 6/4. 3/2 is the same as 6/4, which is the same as 6/9, which is the same as 1 1/2 wholes. So our constant of proportionality for all of this is going to be 3/2, or 1 1/2. It means that Andrea can draw 3 portraits in 2 hours, or she can complete 1 1/2 portraits in 1 hour. That constant of proportionality, the value we use for K, is going to be that unit rate, or the value of the ratio, just like we've been finding before. Okay, make sure that all of this information is in your notes. We're going to be working in class on this, on the problem set that goes with this lesson, so be prepared. We'll see you in class.